All right, continuing on with the 2021 AMC 10A problem 19. The area of the region bounded by the graph of that ugly expression is m plus n pi. Wait, where do we usually get pi in area? Oh yeah, circles. Probably going to come up, right? Where m and n are integers, that's good to know. What is the sum of those values? Okay. So how do we progress? The way I usually handle these kinds of absolute value one when we're thinking about graphs is I think about what quadrant we're in. So for instance, if we are in quadrant 1 and x is greater than y, then I can pretty much instantly see that we don't need either absolute value. For this one, they're both positive numbers. You don't need absolute value for that. And since x is bigger than y's value, this will be positive also. So if I graph y equals x, it's right here. Why did I use the y equals x line? Because that's the only way to think about when x is greater than y, right? You set y equals x and then it will be below that line. So what happens then? We would get x squared plus y squared equals 3 times, I'm going to factor out this 3, and it's just going to be x minus y plus x plus y. No longer needing absolute value, right? So then we're going to have 2x because the y's are going to cancel. 3 times 2x is 6x. Let's get it over here. X squared minus 6x plus y squared equals 0. Why did I leave a space? Because if you had conic sections, you know what's coming next. We're completing the square to make a circle. So we're going to cut this negative 6 in half. If you haven't had conic sections, hey, don't feel bad. If you're lower grade and you haven't had a chance to learn some of these topics yet, that's why there's room to grow. This is the things you're going to be learning in the future, the things you can learn for next year. So don't feel bad if you didn't ever do this before. That's fine. Now you know something that you can learn for next year, and you attack that. Okay? So the negative 6 cut in half is negative 3. You square that negative 3 to get 9. You will add it to both sides. So what does that mean? This is now a perfect square trinomial. Again, if you don't know how to complete the square, then maybe you could look that up on Khan Academy. Plus y squared equals 9. This is a circle with center at 3, 0 and radius 3. Let's get it started. 1, 2, 3. Here we are. Radius 3. 1, 2, 3. We'll go here. 1, 2, 3 is actually on this line, and there's a quarter circle there. But we're not going to keep going that way because that would mean y is greater than x, which we have to think about differently. So we're going to go to here, but all of the space underneath that line is still acceptable. And as you can see, we've got a quarter circle and a triangle, and I suspect symmetry is at play. So let's look also in quadrant 1 and assume that y was greater than x. Again, you still won't need this one. The absolute value of a minus b, you got to memorize this stuff. It's just a minus b if a is greater than or equal to b. And it's b minus a if a is less than b. In other words, if you just switch the order, is all you do. You can get rid of the absolute value and switch the order when the one on the right is larger. Pretty simple, right? So this is going to become y minus x now. So just instead of thinking of this as x minus y, think of it as y minus x. What would have happened is the negative x and x would have canceled. The y's would have combined now to get 2y times 3 moved over. Now it's just going to be x squared plus y minus 3 squared equals 9. Right, you don't have to show all the work. You're not proving this to anyone. During a competition, feel free to just skip steps once you know you have to be 100% sure that's what's going to happen. And I am, because moving over 6y is not any different than moving over 6x. And since I had x squared and y squared, it just means the y is the one to get the minus 3 now, right? So this is going to be 0, 3, which is the center. And then the radius is still 3. So we go up here, 1, 2, 3, and there's our center. We go up 3 and over 3. Oh, look, that looks like a quarter circle. And you've got the triangle here because that would be included also. Next up, let's just kind of confirm our suspicion. Let's go to quadrant 2. In quadrant 2, we would now say that y is the absolute value of y, which is positive anyway, is going to be greater than the absolute value of x. Okay? If that happens, right, because x is negative in the second quadrant, I don't need absolute value on this. because the positive number is bigger than the absolute value of the negatives. This will come out positive as well. So I would get x squared plus y squared equals 3 times, let's just write that one now, just x plus y. What about this one? Well, let's just say, like we said, we want to be kind of up in this region up here where y is greater than the negative x value. So if that happens, I would have a negative here minus a negative here. That's a negative number, right? A negative minus a positive just gets more negative. Therefore, we know this expression in here is negative, and we just follow this rule and switch the order. And it's back to y minus x with the x's canceling, 2y, shift over. It's this one again, but now we're in the second quadrant. So we're going to come over like this. There's our quarter circle. There's our, this is just repeating. We got it. You got to make that call at this point that you're going to get symmetry all over with this. There probably is a way to test for symmetry, and we could do that. In fact, yeah, we could probably do it, but I don't want to do it right now. It's been a long day. So learn how to test for symmetry with the x-axis and the y-axis. It's just a matter of replacing, like if you want symmetry with the origin, you would replace x and y with negative x and negative y in all the expressions. And if you get the same expression, then it's going to be equivalent, right? But the absolute value makes it more complicated, but I just have high confidence we're going to have symmetry here. And so what does that mean? You're going to come down like this, have another quarter circle here, and what do you have then? This is going to look the same thing down here. You're going to have a square that goes like this, and it's going to be 3 here and 3 here, total of 6. And so the area is actually just the curved part, right? That's actually the thing that we're drawing, but it's everything in that shape, which is why we can capitalize on this square as well. So we've got 3 here, 3 here, that's 6 times 6 is 36, plus 1, 2, 3, 4 quarter circles is a circle. There's another circle that's the same size down here. It's 2 circles of radius 3. So it will be 2 times pi times r, which is 3 squared. And that's 9 times 2 is 18. You get 36 plus 18 pi. 36 and 18, 54, because we're supposed to add m plus n. A pretty challenging problem. Try to remember the technique of thinking about one quadrant at a time. That's been the easiest way for me to attack this problem type. We're on to the next problem.